All right, we're in section 10.1 where we're going to use properties of tangents. So we're getting into looking at circles and the different properties that circles can have. We have some terms here on the left, and we're going to kind of review those. Some of them you've seen before, some of you have not. The first one is the center, and so the center is going to be right here. It's the point that is directly in the middle of our circle. The next one is the radius. It's this red line segment right here. And it's a line segment that connects to the edge of the circle and goes to the center of the circle. Next is a chord. Chord is this blue line segment. A chord is any line segment where their endpoints are on the circle, and then there's the more specific chord, which is the diameter, which is right here. The diameter is also a chord because the endpoints are on the circle, but the reason why this one gets a different name is it also crosses the center of our circle. Next term here we have secant. This is the secant. A secant is a line, so if you see it's got arrowheads, it's not a line segment, it's a line that intersects 2 points. So we got 2 points that intersects here and here, so it qualifies as a secant. And then the final one is tangent. So this is our tangent line, and by definition, tangent is a line in a plane of a circle that intersects a circle at exactly 1 point. So we're going to say that it touches the circle at one exact point, and that makes a tangent. All right, so one of the things that we're going to look at, it says use a diagram to answer the questions. The first question they give us is find the radius of circle A. So since we're on a coordinate plane here, we're assuming everything is 1 unit, so it looks like we got 1 unit here, 2 units here, so our radius is going to be 2 units in measure. Then they want us to find the radius. Oh, I'm sorry, you want the radius and the diameter of circle A. So if I go here, just changing the color, it's going to be 1, 2, 3, 4, 4 units. Looking at the radius and diameter of circle B, looking at B, it's going to be 1, 2, 3, 4, so it's 4 units. And looking at the diameter, we got 1, 2, 3, 4, 5, 6, 7, 8. So if you can kind of see a pattern, it appears that the diameter is always going to be twice the size of our radius. Most of you guys knew that. Next thing here is they want us to draw all the common tangencies of the two circles. So here's what common tangencies are going to look like. We got our line, and I want to be able to take a line here and make it so that it is tangent, like that. So that would be one common tangency. It's tangent on circle A, and it is also tangent on circle B. So that's one. I bet you we can get another one here, like so. I can do a little better. Represent the tangency. So there is our second common tangency. And then I think I can do one here. And then, so that's the third one. And I can get one over here. So it appears that I have one, two, three, four common tangents. Now, to give you some examples, so like here are some ways you could say like, okay, this one would give you like three. So like if you had like a circle and then like a circle that just touched, so like those two circles were tangent kind of deal. And you could go here and here and also here. So that would make it three. Or if you had two circles that kind of intersected each other, you would have two common tangencies there and there. Or if you had a circle and a circle here, you would just have one, and that would be where these two touch. I think the only one that would be zero is if you had a circle and a circle. This one would have zero common tangencies. Going on, looking more at tangencies of lines and line segments, we have a theorem for tangency. It says, in a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. So we have the center here, and they said that the radius is going to the point of tangency of that line. By definition, when we have that radius touch that tangent point, it is going to be perpendicular, which means that between that line that is tangent and that radius, it's going to be 90 degrees. So we're going to look at some examples to help prove that. The next theorem or next thing we can look at, it says tangent segments from a common external point are congruent. So we have this point that's on the outside of the circle. This is point T is the tangency, point R is the tangency of this circle. They're saying that SR and ST are going to be congruent. All right, so looking back at that first theorem, they want us to figure out if ST is tangent to circle C. So the only thing we have to figure out is we want to see if this is going to be a 90-degree angle. If it is a 90-degree angle, then we can use the Pythagorean theorem to help us solve it because it's going to be a right triangle. So if the Pythagorean theorem works, we can then state that it is a right triangle and then that point is perpendicular and it's also tangent. So we're going to check and see if 12 squared plus 35 squared is going to equal 37 squared. So 12 squared is 144. 35 squared is 1225. And we want to see if it's equal to 37 squared, which is 1369. So I got 144 plus 1225, and that's 1369. So yes, 1369 equals 1369. That checks off. That means this is 90 degrees. I can say yes. ST is tangent. It says here, find the radius R of circle C knowing AB is tangent to circle C. So Since we know that it is tangent, we know that this is going to be perpendicular, so we know what we have is a 90-degree angle. So what they're saying is from here to here is, I'll make it a different color, 50 feet. And from here to here is 80 feet. We want to find the radius. So what we got is 50, and R is the hypotenuse. We have R as one leg and we have 80 as another. So again, implementing the Pythagorean theorem, we could say that A, we'll call it R squared here, plus 80 squared is going to be equal to the sum of R plus 50 squared. So we got R squared here plus 80 squared, which is 6,400. Now we got to remember that this is R plus 50 times by R plus 50. We got to FOIL it. So when we FOIL it, it should be R squared plus 100 R plus 2,500. So what we got, we have two R squares on each side. Those will cancel each other out. And what I'm also going to do is subtract 2,500. So this gets canceled. And so now I'm left with 64 minus 25, so that's 3,900. So I got 3,900 is equal to 100 R. Divide that by 100. R is going to equal 39. And it was feet, so we're going to say 39 feet. So the radius of this circle is 39 feet. So here they want us to find the value of x, assuming line segments are tangent. So by looking at the rule that we talked about on the previous page, it says when you have a point on the outside and they both are tangent here and here, we know that these two line segments are congruent. So all we can say is 2x plus 7 is going to be equal to 3x minus 5. Subtract 2x, add 5, so cancels. I got 12 here. I have 1x or x here, so x is 12. Looking at this one, same thing. Congruent. So I can say that x squared minus 7 is going to be equal to x minus 1 quantity squared. So x squared minus 7, can't do anything else with that, but this, remember, is x minus 1 times by the quantity of x minus 1. We have to FOIL it out, so when we FOIL it out, I get x squared minus 2x plus 1. So looks like the x squareds cancel out. This turn, I'm just going to subtract 1 from both sides. So now I got negative 8 is equal to negative 2x. Divide everything by the negative 2. Boom. So this turns into 4 equals x. And that is being able to use properties of tangents. Hope this helps. Till next time.